Good morning, student. Let's start today's class. Okay. In today's class, we are going to discuss the third number of error detection method, which is called CheakSum. Okay. In previous classes, we have already discussed about two techniques. One is simple parity. Okay. In between simple parity, there is even parity, and one is odd parity. Okay. And the second method is our cyclic CRC. Okay. Cyclic redundance check method. Okay. And the third method is checksum method. Okay. What is checksum? Let us discuss about what is checksum method. Okay. Here a checksum is transmitted along with an block of data type. That means here what happened, the data or the data which we want to send, that data is transmitted with some some bits which is called checksum. Okay. That means we transmitted the block checksum plus our data, that much is transmitted. Okay. Now what is checksum is a calculated summary of a data portion. That means after calculation, what calculation is done, we have seen or we'll see in coming, that after calculation what we get is called checksum. Here checksum is here the operation addition is done. 1s addition is done. After 1s addition of all the data bits, we get some data that is called checksum. Okay. In an example you have understood, uh, well. Okay. uh, then data is divided into segment each of m bits. The data which we want to send is divided into segments of m bits. Okay. In sender side, the segment are added using 1s complement to get the sum. Okay. Sum is complemented to get the checksum. Okay. First of all, the segments of the data is added using 1s complement to get the sum, and the sum is complemented to get the checksum. Okay. Then uh, checksum segment is sent with the data segment by appending this value as a last byte of the transmission. Okay. After receiving it, the first n minus byte are added and checked if the answer is same as the last byte. Okay. Let's see what is the process. Okay. Process is, first of all, word will be added to the previous word. That means the all segments of the our signal, our input signal. Okay. Or sorry, our input message, all segments are added and its total sum is calculated, and then 1s complement of that sum is calculated, which is checksum, and we add that check to our data. Okay. And send to the receiver end. Okay. And receiver end get the data plus checksum, and then calculate checksum by adding data and checksum, and then taking 1s complement. That means here what happened, the receiver gets the data and checksum, and in the receiver end add again added all the data with all the checksum, and get one another checksum. Okay. And then complement 1s complement and get the checksum. Okay. That means in receiver end what happened, the all received data added to each other, and also with the received checksum. Okay. And we get after that we get sum, okay, and 1s complement of that sum is after 1s complement of this sum we get checksum, another checksum. If that checksum we compare that, if that checksum is all zero, okay, after 1s complement of that sum get checksum, and this checksum will or checksum is all zero, then there is no error. If there is no all zero, then there is some error are there, okay. Now let us discuss some example, then we get then you will or you will understand better, okay. Let's say our information is this, okay, total, this is total information, okay, this is our total information, okay, and this is divided in some segments, okay, 4 segments, okay, all segments added or all segments include one uh, information, okay, that all segments, first of all, in this is sender side, what happened in sender side first, this bit plus this bit, okay, here the 1s addition is done. 1s addition is, what is 1s addition? 1s addition is that when carry 1 is coming, then that carry 1 is added again to the sum, okay, in the next step. That means here you see, when adding the first segment and the second segment, okay, we get one carry. Addition is binary addition. Let's say 1 binary addition is 0 and 1 is carry. This 1 and plus 1 carry 1 is 1, okay, and 0 0 then carry is 1 and 1 and 1, 0 plus 1 1, 1 plus 0 1, 1 1 0, 1 is carry, 0 0 is 0 plus 1, this 1 and 1 1 0 carry 1, okay. So this addition is general binary addition, but in 1s addition is this generally binary addition, when we get an carry 1, that carry 1 is added again to the sum, okay, in the next step. This is the difference between 1s addition and a simple addition. Simple addition, we don't count our carry, but in 1s addition we count our carry, okay. So here carry 1 is carry, so 1 is added to the sum, okay, again. Now this is formed, okay, after addition, binary addition, this is we will get, okay. Then with that sum we adding our third segment, okay. This is our third segment, and we after adding the third segment we get this. Here there is no carry, so there is no another addition. So here after we getting sum, we add our fourth segment, okay. After fourth segment we get this, and here also we get one carry, okay. So this carry is added to the sum, okay, and we get this, okay. This is the this is the this is the total sum, okay, total sum of all the segments, okay. Now after 1s complement we get 1s complement, we get this, okay. This is called checksum. 1s complement means if there is 1, then in 1s complement this is 0 became 0. If this is 1, sorry, this is 0, in 1s complement this is 1, okay. That means alternate, 1 is became 0, 0 is became 1. This is 1s complement, okay. So here see, 1 is 0, 1 is 0, 1 is 0, 1 is 0, 0 is 1, 0 is 1, 0 is 1, 1 is 0, okay. So this is called our checksum, and we send, so we send data and checksum, that is these 1 2 3 4 sections of our data, okay. These 4 sections are our, 1 minute, these four sections are our data, and this section are our checksum. Okay, checksum. So this total we send to the receiver end. Okay, and now see what happened in the receiver end. In receiver end, we received information is 1, 2, 3, 4 data bit, data segment, and one is checksum. Okay, now first we add all the segment of our data plus checksum. Okay, in 1s addition. Okay, similar as in sender case. That means first bit and second bit added, first bit and second bit, then we get this. When we get carry 1, that carry 1 is added. Okay, and similarly happened similarly, and we get our sum here. We get our sum of data segment here. Then we add a checksum. Okay, then we add checksum or received checksum, and we get this. This is the sum of data segment plus checksum. Okay, and after this we take 1's complement, that it is all 0. Okay, if this is, since this is all 0, there is no error. If there is only one or only one bit, or two one bit, or three one bit, then here there is an error are there in our transmission. Okay, this is the concept of checksum error detection process. Okay, thank you.